Hello everyone, I'm Cristina. Welcome to another exciting security video. Today, we will talk about an interesting process injection technique and see how it's implemented in actual malware samples. We will reverse engineer the technique and explain how it works with examples. In a previous video, we talked about process hallowing, which is used to inject shellcode and PE files inside other processes. Now we'll look at another method that achieves the same thing. It relies on CallWindowProcA function, which is documented by MSDN here. Besides the official documentation, which doesn't tell us much, there is little info online about how to practically use the function. Let's start playing with this. Notice the function receives as the first parameter a pointer to a Windows function, which will be called to process a message. So this technique can be used to send messages to different windows and also send functions to process those messages. The end goal is to load and execute shellcode and use that shellcode to bootstrap loading of entire PE files. Let's have a look. I have the following AutoIt implementation, which I reverse engineered from a malware sample. DllCall is used here to call a function from user32 library. Each parameter is represented here by two parameters to the DllCall. One is the type and the other one is its value. Notice the first parameter here is a pointer to the Windows procedure. The procedure's assembly code has been converted to an array of hex bytes. We pass a pointer to this array. The next parameter is the window itself. As an example, I'm using the window belonging to Notepad executable, which will be spawned. Notice we're using the 32-bit version because this shellcode is for 32 bits. Finally, we have the message parameter, which is another binary blob of data representing payload to be injected. The final two parameters are 0. They don't matter. Alright, let's see. So we have an executable here. Very simple. It prints a hello world message, which is about 75 kilobytes in size. Not much, but enough to store a lot of payloads. To embed this executable, I will convert it to hex bytes. I have a Python script for this, which generates hex output. The code is straightforward. Let's see. It outputs to a hello.hex file. Notice that it starts with 4D5A, which translates to MZ. The MZ header of the PE file. Okay, so we have the hello.hex file. The outcome of this is that Notepad will be spawned and then forced to process our payload using the window procedure we specified here. Let's see. We have a minor error here. Let's recompile. Great! We have the hello world message and the process tree shows that it actually comes from Notepad process. Very interesting. It terminates. That was a very simple example. Let's look at something more interesting. We have another payload, which is slightly larger at about 100 kilobytes. This payload tries to write something to a protected folder. We've seen in one of the previous episodes that Documents is a protected folder under Windows 10 by default. Windows Antivirus protects it from ransomware, and unknown applications are unable to write here. This payload will try to write a file here, but it will initially fail. There is a warning message after it gets blocked. Great! Let's convert this payload to hex. I've added a message box so we can stop and examine the process. It runs disguised as a notepad process. Click OK, go back to the protected folder, and the file should have been created. This is a very stealthy way to operate under the radar. This technique is very similar in outcome with process hollowing. The difference is that it relies on a more esoteric API function. Alright, to recap, in this episode we've seen a new way to inject shellcode and PE files using the undocumented API function CallWindowProcA. That's all, guys. Hope you enjoyed this one. Thank you very much for your time, and please share with us any comments you may have, and don't forget to subscribe. Cool! Cheers!